The light of Proxima be asterisk asterisk. The stars hung like scattered diamonds across the velvet canvas of the night sky, each one a silent witness to the universe's infinite mysteries. On a quiet evening in June 2025, Dr. Elena Marquez stood on the balcony of NASA's Goddard Space Flight Center, her breath visible in the cool Maryland air. Her eyes traced the constellations, but her mind was light years away, tethered to a single point in the cosmos, Proxima b, the closest exoplanet to Earth, orbiting the faint red dwarf star Proxima Centauri. For years, it had tantalized scientists with its potential to harbor life. Tonight, Elena felt the weight of history pressing against her chest. The James Webb Space Telescope, humanity's most advanced eye in the sky, had just delivered data that could change everything. Inside the control room, the hum of computers and the soft glow of monitors created a cocoon of anticipation. Elena's team, astrophysicists, engineers, and data analysts, huddled around a central screen displaying spectrographs and atmospheric readouts. The room buzzed with nervous energy, as if the universe itself were holding its breath. Dr. Rajesh Patel, the lead spectroscopist, adjusted his glasses and pointed at a jagged line on the graph. "Look at this absorption spike," he said, his voice tinged with awe. "It's consistent with methane. And here," he tapped another peak, "possible traces of oxygen. This isn't just noise. Elena, Proxima b's atmosphere is singing to us." Elena's heart raced. She'd spent her career chasing the dream of finding life beyond Earth, but the reality had felt surreal, like stepping into a science fiction novel. "Are we sure?" she asked, her voice steady despite the storm of emotions within her. Could it be geological activity? Volcanic outgassing? Rajesh shook his head. "We've run the models a dozen times. The methane-to-oxygen ratio is too specific. It's biological. Or at least it could be." The room fell silent. The implications were staggering. Proxima b, a rocky world just 4.24 light-years away, discovered in 2016, had long been a beacon of hope in the search for extraterrestrial life. Its orbit within the habitable zone of Proxima Centauri, the so-called Goldilocks zone, where liquid water might exist, had sparked endless speculation. But speculation was one thing, evidence was another, and now, the JWST, with its golden honeycomb mirror and unparalleled sensitivity, had glimpsed something extraordinary. The faint glow of what might be artificial lights, coupled with an atmosphere rich in biomarker molecules. Elena turned to the team, her dark eyes reflecting the glow of the screens. "We need to triple-check this. If we're wrong, we'll be the laughingstock of the scientific community. If we're right," she trailed off, unable to finish the thought. The possibility was too vast, too profound. The discovery of Proxima had begun nearly a decade earlier in the high desert of Chile's La Silla Observatory. There, the high-accuracy radial velocity planet searcher HARPS, a spectrograph of unmatched precision, detected a subtle wobble in the light of Proxima Centauri. The star's gravitational tug revealed an unseen companion, a planet roughly 1.3 times Earth's mass, orbiting every 11.2 days. The news sent shockwaves through the astronomical community. Proxima b was not just another exoplanet. It was the closest one ever found, a cosmic neighbor in our galactic backyard. But proximity didn't guarantee habitability. Proxima Centauri, a red dwarf, was a temperamental star, prone to violent flares that could strip a planet's atmosphere bare. And Proxima b, tightly locked to its star, presented a unique challenge. One side bathed in perpetual daylight, the other shrouded in eternal night. The boundary between these extremes, the Terminator Zone, offered the best hope for temperate conditions, but only if the planet had an atmosphere capable of distributing heat. For years, scientists debated Proxima b's potential. Was it a barren rock, scorched by stellar radiation? Or could it cradle oceans, forests, or even cities built by intelligent beings? The questions gnawed at Elena, who joined NASA's Exoplanet Division in 2018, fresh from her PhD at Caltech. She'd grown up in a small village in Peru, where the Milky Way blazed so brightly it seemed to whisper secrets. Her grandmother, a Quechua storyteller, had taught her to see the stars as ancestors, guiding humanity toward its destiny. Now, as a scientist, Elena sought those same truths through data and discovery. The JWST, launched in 2021, was her greatest ally in this quest. Unlike its predecessor, the Hubble Space Telescope, the JWST was designed to peer into the infrared spectrum, capturing light from the universe's most distant and enigmatic objects. Its 6.5-meter mirror, a marvel of engineering, collected photons that had traveled billions of years, revealing the birth of galaxies and the atmospheres of far-off worlds. For exoplanet researchers like Elena, the telescope's ability to analyze starlight filtered through a planet's atmosphere was a game-changer. The technique, known as transit spectroscopy, relied on a simple principle. When an exoplanet passed in front of its star, some of the starlight passed through the planet's atmosphere, leaving behind a chemical fingerprint. By breaking this light into its constituent wavelengths, the JWST could detect molecules like water vapor, methane, carbon dioxide, and oxygen, potential signs of life. These biomarkers were the holy grail of astrobiology, and Proxima b, despite its faintness, was a prime target. Back in the control room, Elena's team worked through the night, refining their analysis of the JWST data. The telescope had observed Proxima b during a rare transit, capturing a sliver of light that had passed through its atmosphere. The spectral data was a treasure trove, revealing not only methane and oxygen, but also traces of ozone, a molecule often associated with biological processes on Earth. But the most startling finding came from a separate observation, a faint, periodic glow emanating from the planet's night side. Dr. Sarah Nguyen, the team's imaging specialist, pulled up a heat map on the screen. "This isn't natural," she said, her voice trembling with excitement. "The light is concentrated in specific regions, almost like cities. It's too structured to be volcanic or auroral activity." Elena stared at the image, her mind racing. Artificial lights? The idea was almost too fantastical to entertain. Yet the data was unambiguous. The glow waxed and waned in a pattern consistent with a rotating planet, suggesting illuminated structures on Proxima b's surface. Could it be a civilization? Or was there another explanation? A network of reflective ice, perhaps, or some unknown geological phenomenon? "We need to be cautious," Elena said, breaking the spell. "This could be a false positive. We've seen stranger things in the cosmos." Rajesh nodded. "Agreed. But the atmospheric data corroborates the light signatures. The methane and oxygen levels are in equilibrium, which is hard to explain without biological activity. And the ozone is a strong indicator." Sarah leaned forward, her eyes bright. "What if we're looking at a world like Earth, but different? A civilization that evolved under a red dwarf, adapted to tidal locking. They might not be human, but they could be something." The word hung in the air, heavy with possibility. Elena felt a chill, not of fear, but of wonder. She thought of her grandmother's stories, of worlds beyond the stars where life danced in forms unimaginable. Was this the moment humanity had been waiting for? The proof that we were not alone? The next morning, Elena met with NASA Administrator Dr. Thomas Whitaker in a conference room overlooking the Potomac River. Whitaker, a former astronaut with a weathered face and a reputation for blunt honesty, listened as Elena presented the findings. She walked him through the spectral data, the biomarker detections, and the anomalous light signatures, her voice steady despite the stakes. Whitaker leaned back in his chair, his fingers steepled. "You're telling me we might have found a city on Proxima b? Lights, atmospheres, the whole 9 yards?" "Not definitively," Elena said carefully, "but the data is compelling. We need more observations to confirm, and we need to rule out every alternative explanation. Stellar flares, instrumental errors, you name it." Whitaker's eyes narrowed. "If this leaks before we're ready, it'll be a circus. The public's already obsessed with aliens thanks to every sci-fi movie and ex-post out there. We need to control the narrative." Elena nodded. She'd seen the frenzy that followed unverified claims of extraterrestrial life, conspiracy theories, viral memes, and breathless headlines. But this was different. The JWST's data was rigorous, peer-reviewed, and backed by years of preparation. Still, she knew the risks of announcing a discovery too soon. "I want a press conference in 2 weeks," Whitaker said. "Give me an airtight case by then. If we're going public, We're doing it right. As Elena left the meeting, her mind churned with questions. What did it mean to find life on Proxima b? Would it be microbial, like Earth's earliest organisms, or something more advanced? And if those lights were artificial, what kind of beings created them? She imagined a world of crimson skies, where creatures adapted to a tidally locked planet thrived in the twilight zone, their cities glowing against eternal night. Over the next 2 weeks, Elena's team worked around the clock, cross-referencing their data with simulations and consulting with experts worldwide. The JWSD conducted additional observations of Proxima b, capturing more transits and refining the light curve analysis. Each new dataset strengthened their case. The atmospheric biomarkers were real, and the night-side glow was consistent with artificial illumination. One evening, as Elena pored over the latest spectral readouts, Rajesh burst into her office, his laptop in hand. "You need to see this," he said, setting the device on her desk. He opened a 3D model of Proxima b's atmosphere, based on the JWSD's data. The simulation showed clouds of water vapor swirling over the planet's dayside, with pockets of methane and oxygen concentrated near the terminator zone. "It's dynamic," Rajesh said. "The atmosphere isn't static. It's responding to something. Maybe weather patterns, maybe activity." Elena's breath caught. Activity was a loaded term, implying not just life but intentionality. She zoomed into the model, watching as the chemical signatures shifted in real time. It was as if Proxima b were a living, breathing world, its atmosphere a canvas painted with the signatures of existence. The team's findings also raised new questions about Proxima b's habitability. Tidal locking created extreme conditions. The day side could be a scorching desert, while the night side might be a frozen wasteland. But the terminator zone, where day met night, offered a narrow band of potential habitability. If liquid water existed there, perhaps in oceans or underground aquifers, it could sustain life. The presence of water vapor in the atmosphere was a tantalizing clue, but direct evidence of surface water remained elusive. Another challenge was Proxima Centauri's volatility. Red dwarfs were notorious for their flares, which could bombard nearby planets with radiation. Yet Proxima b's atmosphere appeared intact, suggesting a magnetic field or some other protective mechanism. Elena wondered if the planet's geological activity, volcanoes, tectonic shifts, played a role in maintaining its habitability, or if life itself had engineered solutions to survive. On the morning of the press conference, Elena stood backstage at NASA's headquarters in Washington, D.C., her palms sweaty as she rehearsed her opening remarks. The auditorium was packed with journalists, scientists, and dignitaries, their murmurs rising like a tide. Outside, the world watched via live stream, from coffee shops in Tokyo to classrooms in Nairobi. The announcement had been teased as historic, and speculation ran rampant on X, with hashtags like #ProximaLife trending globally. Whitaker took the podium first, his voice calm but commanding. "Today, we stand at the threshold of a new era in human exploration," he began. "The James Webb Space Telescope has given us a glimpse into the atmosphere of Proxima b, the closest known exoplanet to Earth. What we found is extraordinary." He introduced Elena, who stepped into the spotlight, her heart pounding. She described the JWSD's observations in clear, measured terms, walking the audience through the detection of methane, oxygen, and ozone, and the mysterious glow on Proxima b's night side. She emphasized the need for further study, but didn't shy away from the implications. "These findings suggest that Proxima b may harbor life," she said, pausing to let the words sink in. "Whether that life is microbial or something more complex, we don't yet know. But for the first time, we have evidence that we may not be alone in the universe." The room erupted in questions, hands shooting up like stars igniting. Elena fielded them with precision, deflecting sensationalism while stoking curiosity. When a reporter asked about the city lights, she smiled. "We're calling them light signatures for now. They could be natural phenomena, but their pattern is intriguing. We're scientists, we follow the data, not our imaginations." That night, as Elena watched the news cycle explode with headlines, "NASA finds signs of alien life," she felt a mix of exhilaration and unease. The public's reaction was a double-edged sword, awe at the possibility of extraterrestrial life, tempered by fear of the unknown. On X, posts ranged from jubilant memes to dire warnings about alien invasions. Elena scrolled through them, her mind drifting back to her grandmother's stories. The stars, she'd said, were a reminder that humanity was part of something greater. Now that something felt closer than ever. In the months that followed, Proxima became a global obsession. The JWST continued its observations, joined by other telescopes, and planned missions to study the exoplanet's surface and magnetic field. Scientists proposed ambitious projects, from interstellar probes to laser-based communication systems, to reach Proxima b in the distant future. Meanwhile, philosophers, theologians, and artists grappled with the implications of a universe teeming with life. For Elena, the discovery was both a triumph and a challenge. She led a new task force to coordinate international research on Proxima b, working with colleagues from Europe, China, and beyond. Each day brought fresh insights. A hint of ammonia in the atmosphere, a fluctuation in the light's signatures, a model suggesting seasonal changes in the terminator zone. The puzzle of Proxima b grew.